This is the MATLAB desktop. There's a tool strip at the top of the desktop and some windows along both sides. In the lower center of the desktop is a large white window. It's called the command window, and it's the really important one. Pretty much anything you can do by clicking on the icons or using the other windows can be done by typing commands in the command window. Commands in the command window are typed at this prompt, which looks like two greater than symbols. This prompt is called the command prompt. Commands that can be typed at the command prompt include mathematical operations. So if I type 2 plus 3 and press enter, MATLAB calculates the result and displays it. MATLAB requires that any value you calculate has a name. If you don't provide a name, MATLAB uses the name ANS, which is short for answer, as the default name. The reason for this is that MATLAB saves the results of all your calculations in what is called the workspace. It organizes the contents of the workspace by the names of the variables so that you can access numbers that you calculated later. You can see the contents of the workspace by typing who at the command prompt. Generally, it's not a good idea to just let MATLAB assign all of your variables as ANS, since calling a different number by that same name causes MATLAB to lose the previous value. For example, I'll type 4 divided by 2 and press enter. Now ANS has the value 2 and my previous value is lost. Luckily, MATLAB provides a way of creating your own variable names when you perform a calculation. It involves using MATLAB's assignment operator, which just happens to look exactly like an equal sign. The assignment operator takes the result of a calculation, which is on the right side of the operator, and assigns the result of the calculation to a variable name, which is on the left of the operator. So if I type x equals 3 plus 2 and press enter, MATLAB calculates 3 plus 2 and takes the result 5 and assigns it a name x. Now the who command shows that I have two variables in the workspace, x and ANS. I can see their values by typing the variable name and pressing enter. There are a few rules about what MATLAB will accept as variable names. Let's go over them now. Here's a brief list of the rules for setting up MATLAB variable names. Variable can't be more than 63 characters long. If you try to make a variable more than 63 characters, MATLAB just truncates the name after the first 63. They have to start with a letter. You can't include spaces, punctuation, or mathematical operators, and most special characters aren't allowed. So for example, my .var isn't allowed because it's got a period in it. My space var isn't allowed, and a $sign isn't a legitimate character in a variable name. Underscores are okay, so my underscore var is okay. Variable names are case sensitive, so my var with a capital M is a different variable than my var with a lowercase m. Now let's use MATLAB a little more efficiently. Engineers love to use numbers, and if they don't love it, they have to do it anyway. For example, anytime you run a test, you usually end up collecting a lot of data that ordinarily gets organized as groups of numbers. Since engineers deal with groups of numbers on a regular basis, MATLAB makes it easy to operate on numbers that are organized in groups. For example, I'm going to define a variable named a, and I'm going to assign several numbers to that variable. So I'll type a, an assignment operator, an open square bracket, 0, 1, 2, a semicolon, 3, space, 4, space, 5, and then I'll close square bracket. The square brackets on the right of the assignment operator tell MATLAB that this group of numbers will be assigned a single variable name. Groups of numbers in MATLAB are organized by row and column. When you define a group of numbers, you can separate columns with spaces or commas and rows with semicolons. So in this variable, the first row has the values 0, 1, and 2. The semicolon moves me to the next row, which has the values 3, 4, and 5. So if I press enter, I get this result. The efficient part about this is that now MATLAB will let me use this entire group of numbers in a mathematical operation. For example, if I type b equals a divided by 2, each number in a gets divided by 2, and that entire set of values gets assigned to a single variable name. MATLAB also has a lot of built-in functions which all accept groups of numbers as inputs. So if I want to take the cosine of all the values in my b variable, I can just type C, an assignment operator, cosine, open parentheses, b, close parentheses. Now let's go over some terminology associated with these groups of numbers, provide a little more formal description of how to create arrays, and use some arrays to do a somewhat more realistic engineering analysis of some data. Arrays are organized sets of numbers. For example, A is a 3 by 3 array. It has 3 rows. This would be row 1, this would be row 2, and this would be row 3. It also has 3 columns. So column 1, column 2, and column 3. Another example is X. This is a row vector. It has only a single row. It does have 3 columns. Y is a column vector. It has a single column but 3 rows. A is what's called a 2-dimensional array. Sometimes these are referred to as matrices. It's 2-dimensional because it has both more than 1 row and more than 1 column. X and Y are 1-dimensional arrays, which are often called vectors. So they have only a single row or a single column. There are several ways to create arrays in MATLAB. The only one I've showed you so far is to create it element by explicitly typing every element in the array. You enclose the array elements in square brackets. You can separate columns by either spaces or commas. Rows can be separated by semicolons, or you can press the Enter key to move to the next row of the array. You assign the array name with an equal sign. An example of this is this 2-dimensional array B can be created with B equals, so it takes this set of data and assigns it to this variable name. The first row is 1 space 2. Moving down to the next column with this semicolon, then 3 space 4. Going to the next column with another semicolon, then 5 and 6. I could have commas in here if I wanted. Either thing works. Or I could replace one or the other of both of these with an Enter key. Let's use arrays to specify some data in MATLAB. What I've got here is sound speed in water as a function of temperature. So at 120 degrees F, the sound speed is 5,049 feet per second. At 160 degrees F, the sound speed is 5,101 feet per second. I can put these in 2 separate arrays. Both of those will be 1-dimensional arrays. I'll create them as rows. So this is the temp data. I've put these numbers in a row by separating them by spaces. Commas would work also. They're enclosed in square brackets, and that's assigned to a variable named temp. The variable named SSPD contains the sound speed data. There's my assignment operator. Open square bracket, close square bracket. The data inside here is also set up as a row vector. Now I'll put the data in MATLAB and work with it a little bit. I'll create the temp and SSPD arrays first. Next, I want to plot the data. The MATLAB command is plot. The plot command accepts 2 sets of data, an array of the values on the x-axis and an array of corresponding values on the y-axis. I want to put temperatures on the x-axis, so my command will be plot, open parentheses, temp, comma, SSPD to put the sound speed values on the y-axis. Then I can also set the type of data points and the lines I want to appear on my plot. The codes to specify these styles are placed in single quotes after the x and y data. I want to put red circles at my data points. The code for that is an R followed by an O. Usually data is presented without a line connecting the points, so I'm not going to specify a line style. When I press Enter, a figure window is opened and the plot is displayed. The plot window itself allows you to perform some basic analysis of the data. For example, let's try fitting a curve to the data. Click on Tools and select Basic Fitting. In the dialog box that opens, you can select the type of line you want to fit the data. I think I'll try fitting a quadratic equation to the data, so I'll click quadratic. The line that represents the data is shown on the figure. I'd also like to see the equation for the line that fits the points, so I'll select Show Equations, and the equation is added to the figure. This interface makes it easy to check different types of curve fits, so let's look at using a cubic equation to represent the data. Finally, let's talk a little bit about an example as to why curve fitting can be an important tool for an engineer. Now let's talk about why curve fitting is important. Sometimes we don't have enough insight into the process that's being performed to create a mathematical model from fundamental relationships. This is a big problem since engineering invariably requires us to use math to do our jobs. One way around this problem is to acquire a bunch of data points and use curve fitting to create an equation directly from the data. One area where this approach is commonly used is in characterizing fluid properties. For example, in this reference, they're finding viscosities of oxygen. They decided that that was best represented by a third-degree polynomial and a hyperbolic term of this form. Once they did that curve fitting, they got these coefficients. Now, once you've got this equation, you can use those to generate properties at any temperature and pressure. For example, there's a program called MyProps that was developed with NASA funding, which is what I used to generate fluid properties when I worked at a rocket engine company called Rocketdyne.